those of you who don't know me, I'm Chelsea McDougall. I'm the president of ACM, and we have Herb Lafond here today from Micron, and he's going to talk about what business intelligence means at Micron. Herb was actually the president of ACM when he was here. So
3 decades ago, we won't go into that.
So he's an ISU alum.
Your presence is still felt, Herb.
I'm sure. There's a lot, disturbance in the force going on.
And I'm going to turn the time over to
Okay.
him.
I stink at public speaking. Started emailing back and forth with Chelsea and some of the staff last fall on, okay, I'm coming for the career fair, would be interested in talking to some folks, what are you interested in? And I got this email back, what does BI mean to Micron? Is that something you could talk about? And I'm like, yeah, we could do that. We've got some activity in that area. But I do want to start and kind of paint the backdrop of a condition at Micron that's happening right now that's really driving our business intelligence and analytics environment. Okay? We need to understand where we've come from and where we're at today to really understand the depth of the data problem we have and the BI and analytics opportunities that we face. So I'm going to take a couple of slides and run through some of the stuff about Micron that you may or may not know. Okay? Our mission is to be the world's best memory company by delivering solutions that power our customers' innovation. In reality, a very small percentage of our sales go directly to customers. That's through Lexar and Crucial, and it's a small percentage. The bulk of our stuff goes to small companies that you may have heard of: Apple, Intel, Audi, Facebook accounts. How many have Facebook accounts? Thank you. They're running on Micron memory. Facebook builds all their data servers for their data centers, custom to spec on Micron memory. GoPro. Anybody an adrenaline junkie that has GoPro? Micron memory. Apple. 50% chance running Micron memory. A smart TV. Micron memory. We're the 4th largest semiconductor company in the world, the 2nd largest memory manufacturer in the world, and probably the majority of people don't know what we do because they don't see us directly. They buy other people's products that our stuff is in. Okay, here's a little walk through history. And I realize some of you were not born with these first couple of slides. Humor me for a minute. The little picture down the bottom are the Parkinson brothers, Ward and Joe. They started in a basement office, a dentist office in Boise, Idaho in '78. By 1982, we had an annual revenue of $3 million. That's the initial construction of Fab 1. You can't see this from the freeway driving by. Micron right now is in the center of a monstrous complex.
We're going to see it in real time, Herb.
It is. Okay, 10 years later, 1988, we've gone from $3 million in 10 years to $300 million. That's like 100% growth, or 100 times growth. That's a monstrous growth. We're at 2,200 employees, and we just finished building Fab 3. We're still an Idaho-only company. Jumping forward to I'm going to stop just short of 90, I'm going to go to 1996. 1996, there was a guy who was a student here in the MBA program, had a full head of hair, well, mostly full. This one I left Idaho State and went to work for Micron, okay? I've been on Micron less than 2 years. Email comes out from the executive, says, hey, we just bought all of Texas Instruments memory operations. We doubled in size in 24 hours. Not only did we double in size, but we also picked up operations in Italy, Singapore, and Japan. We'd never worked internationally before. It was 1998. We were looking down the barrel of Y2K. We had this massive IT infrastructure that we had to change in 18 months. Oh, and you have to integrate with another company that you spot. integration and acquisition is going to play a big story going forward. Okay, jump forward to 2002. We buy Toshiba's memory operations. You'll see that our revenue was a little lower than the previous slide. A commodity industry like semiconductors is hugely cyclical. When you buy your iPad, you don't care what memory's in it, you just want it to work. So whoever can make it at quality, the cheapest, they get the business. It's a very cutthroat business to be in. Back in the early 80s, up into the early 90s, there are in excess of 60 to 70 players in the memory business at any given time. It is an all-shoot-all Western war. Moving forward to 2006, we have a joint venture with Intel that's still active today down in Lehigh, Utah. And we jump up to $5.3 billion. Now we're getting significant enough to start drawing some attention in the stock market. You'll notice that our America's capacity output, and that's measured in 300 millimeter equivalents, so it's the equivalent of memory on a 300 millimeter disk. Our capacity jumps up there because our America's footprint, most of it has been converted from 200 millimeter footprint to 300 millimeter footprint. We still make the chips the same size, we just have more silicon to play with. So we're able to produce more. Cruising along a couple years later, we have another joint venture forming Unitera Memories. Again, you start to see the rest of the 300 millimeter spin out. This is the point where our production capability goes nearly vertical. You'll also notice that we have acquired, bought, merged with other companies. Typically when two companies merge, you have two HR systems, two payroll systems, two whatever systems. Some of these acquisitions that we did that were multiple sites, we had one payroll system per site. So it's a logarithmic growth of the variability of the data that we had to deal with over time. You'll also notice that we're doing a merger and acquisition or a joint venture every couple of years. We barely recover from one M&A activity before we jump into the next one. Meanwhile, data is piling up. Please note, data, not information, not usable, lots of data. We acquire mnemonics. This does a fairly large spike in our production capability in Asia. It also lets us get a foot wet in Israel. And there's another company that we bought in the middle of a downturn. It was the industry went into a dip. We had some cash reserves. We bought the company. With mnemonics, we had multiple systems per site in the same system class. Still more and more data. 2013, we acquire Elpida and its subsidiary Rexchip. It's at this point that Micron is literally catapulted into the number 4 semiconductor company in the world, the number 2 memory producer in the world. Our revenue hits $12 billion for the year. Now, I want to point something out. When I hired on here, we bought TI. We acquired software systems that I owned. I hadn't shut them down at this point here. Okay, just keep that in mind. That plays into BI, analytics, and big data. And a really ugly story. Today, if you look at our manufacturing scale, literally the sun doesn't set on Micron. These are our major manufacturing, our product moving sites. There's another 200 sites that are design centers, research centers, sales offices, logistics points, shipping points, globally around the world on most continents. So massive footprint in operation 24/7, 365, everybody producing data. This gives us basically the perfect storm when you're looking at business intelligence. The other piece that kind of adds some interesting twist to our product, when we started out 30 years ago, we made one product and put it on big rolls or in big boxes. It was all the same. We made one thing. If you wanted it, you bought it. If you didn't, you didn't. Today, our customer base is widely varied. They have demands for data. They have demands to have their questions answered. They have needs that we have to be able to answer with data beyond just the interesting twists of the product that they want. So again, more complexity in the market. When we started, we were a high volume memory producer. Now, the real money, the real markup is in the, oh, Audi, you want this type of chip and this type of form factor, this type of speed, and you need 1 million of them a month. We'll make them for you. That's where the money's at. So, that tour through history kind of brings you to the footprint that our executives were looking at about 1.5 years ago. We have dozens of data centers around the globe. We have tens of thousands of servers, tens of thousands of databases, all of them producing data. We have folks in the what's called the information worker community, folks that work with data that have spreadsheets, SharePoint sites, data on whiteboard. I mean, the list goes on and on and on. It's the nightmare of where do you store your data. This definition of what is BI, you can probably find nearly word for word, or something very close in any textbook that talks about BI. This standard definition. There's a couple of pieces that you need to understand, though, going into this discussion in depth. It's not just hardware, it's not just software, it's not moving bits. It's the theories, it's the single source of truth, it's the people. There's a bigger challenge getting people to change their ways than there is laying down new servers for big data. New servers, that's easy. I can do that in my sleep. You want me to get an entire department to give away their favorite spreadsheet and use this thing the corporate IS is giving them? I have to use a gun. They just do not want to give up the old. They don't have trust. That trust hasn't been established yet. Our opportunity, and this is where the beauty comes in, our opportunity comes in to build an enterprise-wide system that pulls this monstrous mountain of data together and presents it to everybody that needs it, when they need it, the way they need it, and then changes in reports, changes in dashboards, changes in metrics in a timely fashion without waiting for lethargic corporate IT to go build them another system or build them another report. So there's a wonderful opportunity to get some excellent growth for the company in this space. Bottom line, we're trying to become more agile. We're trying to get shorter time to market. We're trying to get faster time on decisions by the people that need to make the decisions. So, enough about a textbook. The first one was what I would call the freshman intro to BI 101 definition. This is what I'm going to call the sophomore or junior picture of BI. And it's really simple at a high level. You've got your source systems. Now, it's represented by 3 symbols here. Keep in mind you've got tens of thousands. You've got your target systems, your data cubes, your big data repositories, your data marts. They come with a variety of different names. And then you do something with it and you generate intelligence. You have a report, you have a dashboard, you maybe put it in a cube, you hit it with Excel. You do something so that the people that need to make the decision get the data they need when they need it. Today, we do a fair job of taking this mound of silos of data, getting it out into countless tens of thousands of reports. I can tell you to a quarter of a second what the temperature was at tool number 1 in Fab 17 yesterday. I can't tell you what the temperature is going to be tomorrow. The predictive statistical forecasting, the what's it going to do to me tomorrow, why do I care, what's the relationship What's the relationship between the ambient air temperature and the quality of the deionized water we're using in the fab? How does that relationship work? That's the piece that we need to solve. We're solving it now with brute force. Lots of Excel, lots of human glue. Not very efficient, not very effective. Okay, that's the junior sophomore picture. Now we're going to talk senior grad student picture. Gets a little more complex. There's some things that are key that I want to point out about this fairly dense slide here. First, the green boxes, we have current capability. We're doing transactional, trace, and log data. We're collecting data at insane rates right now. We have reports and dashboards in a traditional BI platform. Okay? What we don't have is Teradata and Hadoop, predictive and advanced analytics. That's a spot that we don't have right now. So those are in yellow. The other pieces I want to point out are the blue arrows around the outside of this diagram, because they tell probably a more interesting story to what's going on. The technology stack, done. Give me enough dollars and I can stand up the technology stack. But there's a couple things you need to understand about once you have the technology in place. Down at the transactional data, you throw records in a database. Governance is very low. It's simple. Up here, your governance needs to be high. The executive in marketing that's looking at the sales numbers for customer X for last week had better be able to trust that that is the number, or bet his career on it. Better yet, bet the company on it. There has to be trust. Trust only comes through governance. Likewise with business value, I got bucket loads of this. Can't use it, can't get value, can't drive decisions. As you work up this chart, you increase business value. If you don't increase governance, I can't increase business value. They go hand in hand. At the top and the bottom, you've got a couple of things that are at play as well. Down here, we've got volume, velocity, and variability. The volume of data that Micron deals with is insane. One wafer through our process, before it even gets into the sales channels, generates gigabytes of data on a short flow. If it's a complex product, it may generate more. The variability of the data, depending on the product line, depending on what the customer wants, depending on the business environment and how it's changing, the variability of the data may change. A data point that was valid last month may not even be of interest today. We have to respond to this in the BI environment. At the top, you've got the hot button for any executive that has a target painted on the back of any IT member right now. You've got the predictive analytics, the big member crunching piece, and you're going to measure those results in hours, sometimes days. Over here, that dashboard needs to be up to the second. You've got a marketing manager that's going to make a multi-million-dollar decision, and he looks at a number, and he makes that call based on the number. It better be accurate, not yesterday's number or a number from 2 days ago. So, huge bunch of information bundled up into one graphic. So you're probably going, okay, you got Teradata, you got Hadoop. You may know what those are and how they play together, or you may not. In simple terms, Hadoop is a large dump truck. In previous life, I worked at an open pit mine, and our ore haulers would haul 170 ton of earth in a load. That's what Hadoop does. It's fairly inexpensive. It does good batch query support. It's the big behemoth bucket of data. The key point for Micron is this scales to multiple petabytes. We've blown past terabytes. We're now looking at petabytes and beyond. Teradata is massively multiple processors all at the same time. This is where you get your speed. Sports cars are very good at what they do. They go very fast, but they can't haul 200 ton of data. Two different tools to solve two different problems. doesn't move as much data. This will eventually scale out to hundreds of terabytes, possibly petabytes. We'll have to wait and see. So we have to have two different tools to play that middle layer in the previous graph. Talked about people before. We stand up all this technology. We've got the business excited. They get the tools that they need to use, but we have to keep the thing running from an IT perspective. That's where this slide kind of comes in. At the top, you've got operations. That's your break fix guys. Keep the servers up. Keep the servers patched. That type of activity. The next bullet down, you've got enablement. This is where IS actually provides consultants to go out into the business units and say, okay, Mr. Business User, here's this tool. Here it helps you solve this problem this way. You want to look at the data through this tool as opposed to that tool because of the way it presents the data. It's actually consulting. It's internal. You've got incremental enhancements. These are typically small term, sub $10,000, sub 250 man-hour efforts to make small changes. You know, add a column to the report, change a graph, those types of things. Then you've got project work. These are the large executive sponsored, executive approved projects that run with budgets of $500,000 upwards to $2 or $3 million. These are the big rocks. When these guys get done delivering a new product to the customer base, they have to transition it to operations to keep the lights on. So it's a circle, it's a cycle, and they'll have to work together. If one of them fails, the entire process fails. If enablement doesn't work, we can build the best platform on the planet, but the business can't use it. So they're just as important as the guys that make sure that the new platform stays up and stays current. The other piece to look at, kind of another slice on this, is if you look at the architecture. The big boxes here are corporate IT supported platforms, data sources, and common tools. The gray boxes are provided by the business. We have auxiliary or shadow IT operations in Micron. Years ago, we tried to shut them down. Today, we're trying to empower and enable them. They're very agile, they're very dynamic, they jump in, they solve a problem. Once they get to a point that grows larger than their team, goes to other sites, other departments, goes globally, then they transition their systems that they built to corporate IS for long-term support. We have data that doesn't come from corporate IT managed systems. We have data that still comes from spreadsheets, and we probably will for several years. You don't write a system for everything on the planet. You get some super smart PhD physicist working on a project, he doesn't need a system, he needs Excel. We've got BI metadata and ETL metadata. ETL is extract, transform, and load. That's the stuff that pulls data out of the online system, the OLTP, and pushes them into the BI environment. In here you've got the process that actually builds the platform on the picture I drew before. Then your IW community comes to work. They take this data that's been semi-processed, sometimes fully processed, you can actually get information out of it, and they deliver BI products to the decision makers. And the decision makers aren't necessarily the executives in the C-suite. Sometimes they're the guy on the shipping dock that receives a batch of chemicals in, and he has to know how to dispense that batch of chemicals, whether it goes over to this place or over to that place. Okay, again, freshman sophomore picture. Here's what it looks like in an org chart. The big kind of blue outline box here is corporate IS. And you've got program managers, talent managers, service delivery managers. You've got the gambit of characters that work in this space. Somebody's going to say, dude, your slide didn't render right. There's no lines in your org chart. There's not. We're a matrix organization. This VIE, this engineer, may owe 30% of his time to this project manager and 30% of his time to this service manager. And the three of them work together with a talent manager whose sole job is to make sure that his career moves forward. So it's very dynamic on the IT side. You get that partnership bar where we actually bridge the gap over on the business. The blue boxes are the business areas, and the green boxes are kind of the roles in those areas. Those are just some of the folks that are going to consume the data created by this partnership and build the information tools that the decision makers are going to consume. Okay. So, one last slide, then actually got this one more, and then we'll do some questions. You might be asking, what kind of tools are you going to use? Well, we've got SSIS, Perl, C#, Hadoop, obviously, Microsoft SQL Server, Oracle, Sybase IQ. Go back to the original problem I described with the merger and acquisition cycle that we've been through for 20 plus years. And you see that we've got a lot of technologies, a lot of platforms that we've got to pull together into this piece. The executive or the decision maker doesn't care that that data point came out of Oracle or Microsoft or Sybase. What he cares about is it accurate, is it timely, can I make a decision with it? On the reporting and analytics side of the house, you've got your business intelligence analysts. They work in the tools, business objects, Microsoft reporting services, data visualizations, quick answer service. This is cool. You give a manager a report, and some of you have had real world experience have done this. What's the manager do first thing? He doesn't thank you, he doesn't compliment you on your report, he doesn't make a comment about how fast it was. He goes, oh, okay, my next question is, you didn't ask me to solve that question, boss. The quick answer service is critical, jumping in and solving those one-off, high payoff questions very, very quickly. Okay, so pulling the technology last half of the presentation back to the goals and strategy on the first part of the presentation. Where Micron's headed right now is we have to grow our BI and analytics space to the next level. In fact, we want to not grow it to the next level, we want to leapfrog to be where we need to be in several years. We have to be aligned with strategy, or is it no value? We have to align with our mission statement and our values. What we're looking for conceptually is the intersection between government solutions and reporting. We're looking for the sweet spot right here in the middle, where we can deliver the answers that need to be delivered to the people that need them in a timely fashion. You can read through the list of our focus areas. There's a couple of big things down here. We've got some technology hurdles we've got to challenge. You know, it's not easy standing up a 100 petabyte data center. You know, that's not small potatoes. Doable, just a lot of work. The cultural change, how do I pry a spreadsheet out of an engineer's hand? If you guys can bottle that, then you're very rich. How do I drive data integrity and trust? Sure, your answer is $7.2 billion for customer X, blah, 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 but did you know, and there's always a but, did you know? How do we get to the point where it's not questioned because it's right? And how do we get faster decisions made? That's really the value spot for Micron. That's the beautiful part. The technology is going to fall into place. I guarantee you, you've got smart people who are going to work their tails off to make the technology work. It's the softer side of the equation that is the challenge. So, we need 3 slides in about 32 minutes, which is my normal cadence. If you've ever seen me talk before. What are you guys' questions? Who's got the first question? You got a question? Always got a question.
So as you're looking to expand the capability, you mentioned you mentioned some of the languages and the documents you're using, but on your report, what types of things are you looking for? What do you think is going to be the most valuable piece of information you can pull out of the data?
I'm going to kind of twist your question on the side a little bit. What's going to be most valuable is if I can get that information to the decision maker on his phone or his tablet or his laptop while he's walking between meetings in the hallway. If I can get it to his mobile device in a timely fashion and tell him what he cares about, that's where the most value is going to come. Today, there's lots of, what's our competitors doing? What are we doing? How do we fare? What's our product error rate? There's lots of those things that are of interest to different people, but getting it to the right people at the right time is critical. See, I told you everyone you're sitting in front. Yes, ma'am.
My question is, one of the slides showed it a little bit. Can you talk a little bit about the difference between predictive and prescriptive analytics? Is that what you're talking about when you want to be the leader of the pack?
So, if you look at something like, as simple as 70 parts per million nitrogen in a chemical stream going to a particular recipe. And we know that at 70 parts per million, it gives this percentage yield rate of the finished wafer. Okay? The smart guys will look at other things and say, well, what happens at 75? What happens at 65? And you can tweak those recipes. We have engineers who tweak recipes on the fly all the time. And you tweak that recipe and you see what it does at maybe going from 70 to 75. Then you get into, you've got two historical data points. Then you can get into the, okay, if we've moved it this much, I can predict if I go to 90 ppm, I'll get this behavior. That's where that's a very, very simple piece with just 2 or 3 parameters. These guys are doing multivariable analysis, looking at thousands of variables. So it's not the type of problem you can solve easily with a spreadsheet. See if my baseball career paid off. It didn't. Yes?
So what advice would you give to somebody that wants to pursue a career in business intelligence or even data science inside of that?
Okay, you're going to need a couple things. You're going to need a fair grasp of technology, okay? You're going to need skill sets like basic SQL queries, how to get data out of a database. You're going to need, and some of you will cringe, you're going to need a good understanding of statistics. You're going to need to know the difference between a mean and a median. Because trust me, I get into discussions with engineers that, no, you don't want the mean, you want the median, and this is why. SPC charts. You know the goofy little SPC charts and the 7 rules for determining if your process is out of control? You know, the average mechanical, chemical, nuclear engineer thinks if you're outside the lines, you're out of control. They miss the other 6 points of the predictive capability of that tool. That's not rocket science. That's stuff that you guys get here. Have that strong base. Okay? You're going to need customer skills. You're going to need to be able to get out and talk to people. You're going to need to be able to listen to an engineer or a marketing guy or a sales guy or a finance guy say, yeah, I want a blah, 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 by blah, 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 blah. He's going to use his language. Then you've got to be able to take that language, turn around and go talk to the geeks, the guys that you feed pizza and coding specs in the door, and say, okay, what the customer wants is this. And if you can get that right, that's a critical skill to have. Attention to detail. Literally, I get between 100 and 300 emails every 24 hours. If one of them falls between the cracks, my boss gets carbon copied on an email within an hour saying, Herb dropped the ball on this again. So, attention to detail at a pace that you've probably not experienced before. And be flexible. 20 years ago, Visual Basic 6, it rocked. It solved all my problems. If I can't do it with Visual Basic in the database, it can't be done. Today, we're not slinging a lot of VB6 code. You have to adapt with technology, with the tools. You have to adapt with business. Yes, ma'am.
What challenges do you have with transmitting data between your international offices and the US?
For the majority of our major production sites, we have a minimum of dual T3 data connections on different carriers between each site. Some sites have larger providers depending on data needs. From our corporate data center in Boise, to Singapore, and some of you technical guys will get the reference here, some of the rest of you won't. My average server-to-server ping time is 130 milliseconds. When I reach out into China, who slows traffic down, they monitor traffic, they block traffic, they play all kinds of games at the border, I get about 170 millisecond ping time, server-to-server. We have built monstrous data pipes between the sites because we move around monstrous piles of data. See, there's a reason they didn't have a basketball scholarship. Yes? Want to be so much better at this.
On one of your infographics where you have a lot of data with Hadoop and Terra data, there were some of the portions that were green and some of them were light yellow. Mentioning that the greens were the ones that you guys already had that skill. And the yellow was one of them. We were thinking about somebody who's looking to trade Hadoop. Is that more of a business side or more on the technological side? You need to know high or big or versus the analytics side of it, you know?
So-
Clear my question a little bit?
So I might have got it confused. You're asking who picked the tool, or what kind of candidate is suited for the tool?
Right, that's probably a better question.
Okay. The tool set that our corporate architects pull together is really based on what problem we need to solve. Okay. The tool sets that are listed up there are the short list. If we come up with a problem we need to solve with a different tool, or solved better with a different tool, then it's evaluated and brought in. Likewise, with the people working with those tools, literally up until 12 months ago, Micron, with 32,000 employees globally, had never posted for anybody with Hadoop knowledge. We had nobody with Hadoop knowledge. We had to go out and grow that internally to get smart enough just to ask the question. We leveraged some consultants that kind of helped us plot that course, and we got to a fair